Hello everyone. So today we're going to go over section 2.2, using the tangent ratio to calculate lengths. So in a right triangle, we can use the tangent ratio opposite over adjacent to write an equation. And if we know the measure of an acute angle and the length of a leg in a right triangle, we can determine the length of the other leg. And this kind of using a tangent ratio to find the length of a leg is called an indirect measurement. So in our first example, we are given that angle D is equal to 35 degrees. This is a right triangle. And so what we can do is label from the perspective of D, which means that this side, CE, is the opposite side. The side DE, 12 meters, is the adjacent side. And the side CD is the hypotenuse. So once again, this is CE, the opposite side, DE, the adjacent side, and CD, the hypotenuse. Another way to label this triangle is to label it with lowercase letters opposite to the angle indicated. So in this case, CE is also lowercase d, DE is also lowercase c, and finally CD is also lowercase e. Okay. So to set up our tangent ratio, we have tangent D, the given angle, is equal to its opposite side over the adjacent side. And we know the measure of angle D is 35 degrees. The length of the opposite side is not known to us right now. So that is just the letter D. And the adjacent side has length 12. We can now multiply both sides by 12. And notice that the 12s will be eliminated. And on the left-hand side, we are left with 12 tangent 35 degrees. Which is equal to D. And of course, 12 tangent 35 degrees can now be evaluated using a calculator. And 12 tangent 35 degrees gives us approximately 8.4 meters. Okay, so that's the first example. In our second example, we are looking for the length LM, which we can also label as N, since it is opposite angle N. So here we have tangent L is equal to opposite over adjacent, just like in the previous example. We can then substitute the values that we know. So angle L is 70 degrees. The opposite side is 20 centimeters long. And the adjacent side is unknown. It is N. So in order to isolate N by itself, there are two steps. First of all, we're going to multiply both sides by N. Which eliminates these two n's here. So now we have N tangent 70 degrees is equal to 20. We can then divide both sides by tangent 70. I'm going to rewrite this. And now the tangent 70 degrees will be eliminated from the left-hand side. So we're just going to be left with n is equal to 20 divided by tangent of 70 degrees. Which can then be evaluated using a calculator. Divided by tangent 70 degrees, which gives us approximately 7.3 centimeters. Now, another way of doing this question is to first find angle N, which of course is 20 degrees, since angle L and angle N must add up to 90 degrees. And then instead we can use tangent N is equal to its opposite and adjacent sides. Again, opposite over adjacent. Like so. And tangent 20 degrees is equal to opposite, which is n, divided by 20. And so we just have 20 times tangent 20 degrees equals to n, which we can then evaluate. And we'll get the same answer as before. Once again, approximately 7.3 centimeters. Okay, let's look at one more example. So here we have a ladder leaning against the wall on the top of the wall, and the base of the ladder is 5 feet from the wall. So something that looks like this. This is the wall. This is the ladder. And here's the ground. And the angle of elevation is 35 degrees. This forms a right angle, the ground and the wall. And we're looking for the height, so we'll call this side h for height. And it's simply a tangent question. So tangent of 35 degrees, the angle of elevation, is equal to the opposite side, which is the wall. So that's h. And the base of the ladder is 5 feet from the wall. So this is 5 feet. So we just have h over 5 on the right-hand side. We're going to multiply both sides by 5 and be left with 5 tangent of 35 degrees is equal to h. And h is going to be equal to 5 times tangent 35 degrees, 3.5 feet. Again, that's approximate or rounded. So that's it. So today we went over how to use the tangent ratio to find the lengths of sides, both opposite and adjacent. And that's it for today. So thank you for listening.